This video is part of a series which introduce a new advanced analysis capability for frequency domain response and fatigue. There are 8 videos, of which this is the last one, explaining how to do post-processing of the results inside Patran. As explained in earlier videos, I'm doing the analysis work on a Windows 7 virtual machine on an Apple MacBook Pro. So I'm going to go to the Windows 7 virtual machine and I am going to go to the directory where the results are, and I'm going to show you how to read the Patran neutral files that have been created by the CAEfatigue vibration product into Patran and show them. So in order to do this, we need obviously to have a program capable of reading Patran neutral files like Patran or VMAP or Megapost, and we need a model. I already have a model here included in this database file knuckle.db. I'm going to open up that model and then show how to read in to this model the CAEfatigue vibration results. So this is the model we have. You'll quickly realize I'm not an expert with Patran, but that doesn't matter. So this is the model that exists. It's a combination of solid and shell elements. I can't remember the number. It's a few 100,000 degrees of freedom. So the basic geometry and element information is already there. We have Patran neutral files that we want to read into this model and plot. So I'm going to go to File, Import, and I'm going to import results from a Patran2 element.els file, which is a Patran neutral file with element results. And when I click on that, it is then, because of the nature of these files, going to request information about a template file, because in order to read those results, you also need a template file. I will show you that template file shortly on the disk. It exists in the results set that we created, but I'm going to go and find that. Now, if you are doing this a lot, you probably want to put that template file into the template directory of Patran so that you can pick it immediately from this list, because we're being directed towards a template directory of Patran. I know that template file exists in the directory where we just ran CAEfatigue, which is in C, I think TPL, where we put the test problem library, and there it is. It's results2.res._tmpl. So I'm going to pick that and do OK, and that just tells Patran in what format to expect the results that are about to be read in. Once that is done, you can then go ahead and choose a results file. Now, there are a couple of things to mention here. First of all, before I talk about the results file to choose, we see there's a tolerance specified on this form. It's 1E-6, which seems like a small number, but in terms of damage results, it's not a particularly small number. I'm going to change that to 1E-18 so that we don't lose or omit small numbers for damage that we're about to read in. It's also a file based on connectivity-based elements, so I'm going to click that. But I think that's the default. So if I didn't pick it, I think it would be the case anyway. So then the last thing we have to choose is which of these Patran neutral files to read. The CAEfatigue vibration program writes for each event and for the sum of events. If you've chosen that, it will write a element result for the bottom layer, element result for the top, and element for the worst of those two. Element result being the center result if it's, for example, a quad 4. It also writes nodal results, so it will write nodal result for the bottom layer, nodal result for top layer, nodal result for worst. The difficulty with nodal results is you will have multiple results at each node, at each grid ID, and that might cause problems for post-processing. So in this particular case, I'm going to choose the element result worst, as so. and when I press apply, those results will be read into Patran. So in order to show those in Patran, we will click on the results button, and I now see the results I've just read in are there as CAEfatigue random vibration results, and I now have a set of results: the 0th moment, 1st moment, 2nd moment, 4th moment, damage per second, irregularity factor, life in cycles. In fact, you will see 16 results that correspond with the same columns that we saw in the CSV file. So let me pick one of these results. We can only plot one at a time. Let me plot log of damage per second and press apply, and it will plot those results inside Patran. By default, the element edges aren't shown, so I'm just going to turn those on because I personally find it a little bit easier to see the results if I do it that way. So now we see damage results, log of damage results created by CAEfatigue vibration that are now read into Patran and plotted. And so we have all of the normal capabilities of Patran for plotting these results. The other results that might be of interest, obviously life, damage, irregularity factor, some of the response statistics like the RMS might be a statistic that is of interest, the root mean square. Let me plot that one, and there it is. That's the root mean square. So I'm seeing that the maximum RMS is 34.6 megapascals. We also said that we can plot the mean plus 3 sigma. So that should be 34.6 times 3, about 105. There we have it. There is no mean stress field superimposed on top, so that's all we have. So that's how we read the results into Patran. I'm going to cancel that and just finally show you that's the template file I talked about, and these are the 6 Patran neutral files that we said were created by the program. So that is the last of the videos that I'm going to show. This program is available from any of these 3 companies listed on this slide. Please consult our website, CAEfatigue.com, for updates to the reseller list and for any other up-to-date technical information. Thank you very much.